1.1. Today we're going to be doing inequalities. So let's start on this first example here. Solve the inequality by graphing. So the first thing you want to note is notice how there's a 0 here. That's important. You're always going to need that 0 to start any problem in this unit. So let's write need this. So first, let's write down our pertinent information. So for zeros, we have -3 and 1. The multiplicity would be 1 and 2, which means it's going to cross and touch. The leading term is x cubed, which means our end behavior should be down and up. So notice how when I graph, I'm only going to put the x-axis here. That's because I actually don't care about the y-axis. So let's put our zeros down, -3 and 1, and let's graph. Here's our arrows like that. I cross through -3, and then I'm going to bounce off of 1, and there's a rough graph. Now again, notice how I don't have any y-axis here. That's because we're looking at inequality and we're saying, where is it greater than 0? So again, notice how it says greater than right there, which means we're looking for where it's going to be above your x-axis. So if I highlight that, I can see it's above the x-axis here and here. So my answer is going to be -3 to 1 union 1 to infinity. And there's a complete solution. Now I'll do the same thing algebraically. So luckily, all of you already know this method. Algebraically is going to be using a sign chart. So recall this method. We put our zeros down, -3 and 1, -3, 1. Put your factors on the left. So x plus 3, x minus 1 squared. Let's put our there 4. And put my dotted lines down. And we're going to plug in numbers. So let's say I plug in a number less than -3, like -4. That's going to be negative, positive, therefore negative. Let's plug in a number in the middle, like 0. So that's going to be positive, positive, positive. And plug in like 10 here. That's going to be positive, positive, positive. And look at that. We get the exact same answer, -3 to 1, union 1 to infinity. And really note how we're not including 1. That's because at 1 right here, we can see it's equal to 0, and this says strictly greater than 0. Let's go to our next example. Solve it graphically. So for this one, I gave you the graph. All you have to do is interpret. So let's highlight this. That's greater than or equal to. So we're looking for where it's going to be above the x-axis. So let's highlight everywhere that would happen. I can see that's right here and right here. Also notice that it's equal to 0. So we do got to make note of that. So now I can see my answer must be -2 to 1 with a bracket, since it's equal to 0 here. But it never really hits -2 because of the vertical asymptote. And then we're going to put union 2 to infinity, since we can see that it will never hit 2 because of the asymptote here. And we can see this behavior, we can assume it's going to get closer and closer, but never cross that line. So we'll say it's going to infinity. And there's our answer. Now we'll do it algebraically. So it's going to be very similar. Notice how you have a 0 here. Again, you need that. So that's good that it's already there. We're going to write z for zeros, except for this one, we're going to put every single term or every single number that makes this expression 0, regardless of where it is. So we're going to put 1 and 2 and -2. Now, of course, we know that 2 and negative 2 aren't actually zeros on the graph because it's undefined. So to note that, we're going to put the d as a subscript to note that it's from the denominator. And you're going to see why that's valuable pretty soon. Let's follow the method here. Negative 2, 1, 2. Put our factors down. X minus 1, x plus 2, x minus 2. Therefore, and now let's plug in some numbers here. So let's say I plug in negative 4. That's going to be negative, 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 therefore negative. Let's plug in 0 for the middle one. So negative, positive, negative, therefore positive. Let's plug in 1.5. So positive, positive, negative, negative. Plug in 10. So that's positive, 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 positive. And it says greater than 0, so we're going to circle these. Now, if we're doing it algebraically, that means we don't have the graph to look at. So here's what we'll do. We'll write the numbers down, negative 2, 1, union 2 to infinity. And we're going to fill it in using the equation. So if the equation is this thing right here, let me grab it. We know that this thing is greater than or equal to 0. What you do is you look at this and think, can it be negative 2? Well, no, because it's from the bottom, the denominator. So meaning you can look up here, there's a d by it, which means we don't include that value because it couldn't be that value. But look at the 1. The 1 is the actual 0 of the function, which means we include it. And then 2, same thing, it's on the bottom, or you can look over here, there's a d attached to it, which means you do not include it. And there's our answer. And notice how it's the same thing for both of these. So our last example is right here. We're going to do this algebraically, meaning we're not going to graph it. So what we're going to do is we have to create the 0. So you really have to understand that you need a 0. You do not want to multiply by x plus 2 here. So if you were to do this, never do this. This would be a fatal error. You will lose all credit on this problem if you do this because that's no progress towards solution. You can't do this because you don't know the value of x, so you don't know how it's going to affect the inequality. Because if x is a big negative number, it's going to affect that sign, so you don't want to deal with this. So make sure you put that note, never do this. Never do this. What you need to do is create a 0. So I'm going to subtract 3 from both sides, like that. Then put a happy face on your 0, because that means zeros are great. You love 0. From here, get the common denominator, so 4x plus 5 over x plus 2 minus, and that's going to be 3x plus 6 over x plus 2. Let's put it together. So that is x minus 1 over x plus 2 greater than or equal to 0. So right here, this is the equation you actually want. This is like the true inequality you're working with. Now do the exact same thing we just did. We're going to put, let's move this over here. The zeros here I can see now are 1 and negative 2, but negative 2 came from the denominator, so I'm going to write a d on it, just so I remember that. And I'll do the same thing. Negative 1, oh, sorry, negative 2, 1, x minus 1, x plus 2, therefore, drop our dotted lines down, and let's solve it. So plug in like negative 5, So it's negative, negative, positive. Let's plug in 0, negative, positive, negative. And let's plug in like 10, so all positive. We're looking for where it's less than or equal to 0, so that's my negative 1. So negative 2 to 1. Now look here. Okay, I can't use 2 because it's from the denominator, so put a parentheses. And it can be 1, so put a bracket. And I'm only doing this analysis because of this equal to here. You'll notice if there is no equal to, like let's say for this one, there's no equal to here, we wouldn't do that for a problem like this. So like if that were like that, we wouldn't even put brackets anywhere. But since there is a equal to, that's what makes it a little bit harder. Okay, so that's the answer, and that's it. Let me know if you have any questions, and I'll see you in class.